Well, welcome back after a longer than expected break. Didn't expect the cathedral to break on us, but first time for everything. So last time was supposed to be one of the punchlines, really the first punchline of the course, bringing into view really the topic of the course, what I call reason relations. We saw that first, trying to think about discursive practice as norm-governed in the light of Harman's observations about the difficulties of doing that, particularly as they've been amplified by Macfarlane. And our idea was to look to Greg Restall and Dave Ripley's normative pragmatic bilateralism about the sequent arrow notion of implication, the sequent calculus arrow or notion of implication. Their question was, what do we mean by saying gamma implies delta as a sequent, an object to be manipulated in the sequent calculus? We'll talk about that, the sequent calculus, next week. And their view was, what you're saying is that any position that consists of accepting all the premises in gamma and rejecting all the conclusions in delta is normatively out of bounds. If you're in a position like that, what the sequent is saying, what endorsing that implication means, is that you're treating as out of bounds any position that includes accepting all the conclusion, all the premises, and denying all the conclusions. And we saw that where they're working with a one-sorted normative meta-vocabulary, in-bounds, out-of-bounds, that they're not thinking in the same normative terms, or not officially, about what a position is. We say, well, the position already involves normative statuses, namely commitments to accept and reject, or normatively significant attitudes. And when you're saying out of bound, the position is out of bounds, you mean that constellation of commitments to accept and reject is one you can't be entitled to. There's always going to be some of those commitments. Well, that position, that constellation of commitments, is one you can't be entitled to. So we developed a little their normative pragmatic meta-vocabulary by making it two-sorted rather than one-sorted, the status of commitment and entitlement not just being in bounds and out of bounds, not changing any of the basic ideas. But thinking about implication relations in those terms tells us how we can also think about incompatibility relations in those terms, to say that a set of sentences gamma is incompatible with a set of sentences delta is to say that the position that consists in accepting all of gamma and accepting all of delta is out of bounds. You can't be entitled to all of those commitments. And thinking about reason relations of implication and incompatibility in those terms tells us how to think about them as normatively governing discursive practice, thought of as consisting of the making of claims and then the making of more claims that stand to the original claims as challenges to them or defenses of them. So that was the general shape of our response to the Harman-Macfarlane concern, and it gave us a definition in the normative pragmatic meta-vocabulary of reason relations of implication and incompatibility. But we saw that the same reason relations can be specified in semantic terms in Fine's truthmaker semantics if we tweak his apparatus suitably. None of his definitions of consequence, he defines consequence in terms of entailment and consequence in terms of containment. I'll say what those are in a minute. Neither of those is going to do for us. But if in the truthmaker setting, we understand gamma implies delta as meaning every fusion of any truth maker of all of gamma with any falsity maker of all of delta is an impossible state. That's basically just taking the condition that he called exclusivity and applied to the relation between truth makers and false makers and saying, well, in general, we can define consequence in that way. And if we do, we can show, well, Hlobil shows in chapter 4, how to set up a thoroughgoing isomorphism between the normative pragmatic specification of reason relations and a semantic truth maker specification of it. So in this way, I claim we've put on the table a topic, reason relations, which can be specified either from the side of the use of the language in a normative pragmatic metavocabulary, or from the side of what one is, from the side of the world that one is semantically relating oneself to, as made precise in the truthmaker framework. So we've got two different perspectives on this one topic, the reason relations. In general, you don't pick out a topic until you have two ways of specifying it. Frege taught us this in the Grundlagen, that to introduce an expression as a singular term, as a referring expression, you need to settle the truth values of identities involving it. You may not epistemically be able to tell which of them are true, but your semantic specification must have settled which of the identities involving it are true. And the thought is, otherwise you just have, in Fregean terms, a sense. And you presume that it picks out a referent, but some do and some don't. Present King of France does not. When you have identities involving them, you have two ways of specifying them. Then you pick out an object. You need to triangulate on them. And we've done that by specifying one topic, reason relations, in a pragmatic, deontic, normative metavocabulary, and in a semantic, alethic, modal metavocabulary. Now, what I want to talk about today is those reason relations. Material reason relations, that is, relations of implication and incompatibility that don't yet owe anything to logical relations, to anything specified in logical vocabulary. For an implication, we're looking at something like Pittsburgh is to the west of New York, so New York is to the east of Pittsburgh. The goodness of that implication doesn't depend on any logical concepts or vocabulary. It just depends on the conceptual content of the non-logical concepts east and west. And for an incompatibility, we could say this coin is made of copper is incompatible with its being an electrical insulator. Again, that incompatibility is underwritten by laws of nature, the essence of copper, but no particularly logical things. So our topic for today is the structure of non-logical, I'll call them following Seller's material reason relations of implication and incompatibility. The ones that we can specify pragmatically, we can specify semantically. Now the question is, well, what can we say about the structure of the relations that come into view from those two points of view? Now, for us semantic inferentialists, we're talking about the meanings of concepts. Those material reason relations that they stand in are what, according to semantic inferentialism, articulates the conceptual content of those expressions. So if you're a semantic inferentialist, it's particularly important to know what the structure of material, non-logical reason relations is, because those are the relations that articulate the conceptual contents of all non-logical concepts. But even if you're not a semantic inferentialist, you might be interested in the structure of reason relations. That's the structure of reasons. It's the structure of reason, as the German idealists were fond of talking about it. And I want to do that in 4 pieces. I want to talk relatively briefly about the structure that we can see that reason relations have. And then I want to talk about the structure that people have assumed reason relations have because the reason relations that they knew how to think carefully about were logical ones, and they carried over the structure of logical reason relations to the structure of reason relations in general. And I want to claim, but in fact, material reason relations do not have the structure that logical reason relations have. There's a mismatch between them, which is going to raise a question. Well, so what difference does logic make if sort of ordinary reason relations don't have the logical structure? There's a mismatch of structure between the logic and reasons. What is the relation between these? Well, that's our topic for next week. So the second thing I want to do is talk about what the structure of logical reason relations is and argue that material reason relations do not have that structure. Now, people who have realized that typically did so under the heading, anyway, in the second half of the 20th century and since, have thought, well, the trouble is logical reason relations are monotonic. If an implication is good, it remains good if you throw in any arbitrary additional premises. And that doesn't seem to be true of ordinary reasoning. So what we need is non-monotonic logics. Still, there's some structure. There isn't this structure of monotonicity, but there's some structure. And they've fallen back on cautious monotonicity as a structure that even non-monotonic logics endorse. So monotonicity says if gamma implies delta, then gamma together with any A also implies delta. Cautious monotonicity says, well, no, that's not true in general, but suppose that gamma already implies A. Then, if gamma implies delta, then gamma together with A does as well, because gamma already implies A. So a sort of universal fallback structural assumption has been to retreat from monotonicity to cautious monotonicity. And so the third thing I want to do is to explore what's involved in a commitment to cautious monotonicity and argue that that doesn't apply in globally, doesn't apply generally to material reason relations either. So that's arguing that material reason relations are not just non-monotonic, they're hyper non-monotonic. They not only don't generally respect monotonicity, they don't generally respect cautious monotonicity. And the fourth thing I want to do is explore the consequences of that. Because if cautious monotonicity doesn't hold, if adding consequences of your premise set to the premise set can change what follows from them. If cautious monotonicity says, well, you may lose some consequences, then its dual cumulative transitivity says, well, and you might add some more too. The consequence of that is that the notion of the rational closure of your beliefs, that is, believing all the consequences of the beliefs that you acknowledge, is actually an incoherent notion. While controversies about that notion, well, is it really possible for you to believe all the consequences of your beliefs, to rationally close your beliefs under consequence? Is that humanly possible? If it isn't, can it even be a norm that you ought to? If ought implies can, then it can't be that you ought to if you can't. There's a little controversy about that. I claim the notion is not coherent. The notion of rational closure depends on cautious monotonicity, and if that doesn't apply in general, then we have to think about the process of rationally extracting consequences from your belief as embarking on a path that can take you to different places depending on what consequences what order you extract consequences in. It brings you to different places. And this, I think, has substantial consequences for philosophical thinking about rationality. If all goes well, Ned and I will put on a little dog and pony show for you with a program that explores the explicitation paths. But that's at the end. First, we have to understand sort of what that is. So first, for the structure that we claim material reason relations really have. Well, the first thing is they come in two flavors. There's implications and incompatibilities. That's a real structure that material reason relations have. But if you just say that, it raises all sorts of questions. Why are there two? Why not just one? Why not three? If there are two, why is it just these two? I mean, I haven't said a lot about what those are. Well, actually, we've said how to specify those two in pragmatic normative terms and in semantic lethic modal terms. So we actually have said something, but why those two? And here, I wish I had more to say than I do. I believe that we have all the raw materials for a transcendental argument, that there have to be two kinds of reason relation, and furthermore, they have to be these two kinds. A second point, which we've already hit on, is that those two themselves have different structures. In particular, implication is non-symmetric, although you can have P implying P or P implying Q and Q implying P. Usually that's not the case, and it's crucial for implication that it's not always the case. Sometimes you get to something inferentially weaker from a claim. You can get from P to Q, but not the other way around. If Pedro's a donkey, Pedro's a mammal, but it doesn't work in the other way. That's essential to a relation being a relation of implication. Whereas incompatibility is de jure symmetric. And we saw Ryan Simonelli's clever Dutch book-like pragmatic argument that incompatibility must be symmetric in order to perform its role in challenging claims. And so at this point, we appeal to the pragmatic picture we have of making claims and challenging them by giving reasons against them and defending them by giving reasons for them. And he's appealing to the function of incompatibility as the reason relation that normatively governs reasons against. Well, reasons against acceptance. If it's a reason against denial, then one might appeal to implications. So we've seen that argument. If we ask, well, but we now know that we can think about these reason relations from a semantic point of view as well as from the pragmatic point of view. Is there something to say on the side of semantics that in the truth-maker setting about why incompatibility must be symmetric? And it is built deep into the apparatus of truth-maker semantics that that's true, because what we have is just a partition of states into impossible and possible ones. And the notion of incompatibility, the native notion of incompatibility, is that two states are incompatible if their fusion is impossible. But mereologically, fusion is a symmetric relation, so incompatibility is going to be. Whereas the native, the notion of implication that's really native to the truth-maker setting is that of containment. And indeed, that's one of the definitions of consequence that Fine exploits. That's looking at the asymmetric mereological part-whole relation as the basis. Now, we, in fact, in our use of the truth-maker semantics, appeal both to the modal and to the mereological in defining both of the reason relations. But that's sort of building on top of the apparatus. If we ask why there's two of them, in the pragmatic point of view, from the pragmatic point of view, well, this is just an expression of what I've called the basic discursive bipolarity, which shows up as the distinction between reasons for and reasons against, pragmatically corresponding to the distinction between acceptance and rejection, and semantically to the difference between truth and falsity. But our overall claim is that you can't really understand the pragmatic or the semantic versions of it unless you understand the reasons for and reasons against, understand implication and incompatibility as an expression of that fundamental discursive bipolarity. So I would like to be able to give a sort of transcendental deduction of the necessity of reason relations coming in these two flavors, and furthermore, with the two flavors being distinguished by one of them being de jure symmetric and the other being non-symmetric. Parenthetically, we're going to see that very same structure recur when we drill down below the level of sentences and ask about what contribution the occurrence of a subsentential expression can make to the reason relations that a sentence in which it occurs, what contribution it makes to the reason relations of sentences in which it occurs. And here, there is a transcendental argument that, anyway, I find compelling, that there need to be two basic kinds of subsentential expressions, one of which we're using a substitution inferential scalpel to dissect the sentences. This is week 9, week 10 in the course here, so I'm just waving my hands at all of this. But using a substitution inferential scalpel, we'll see that the subsentential expressions must come in two kinds, one that are symmetrically intersubstitutable, and one that are non-symmetrically substitutable. That's basically singular terms and complex predicates. But a higher level question one might ask is, why does that same structure recur at the level of subsentential structure, division into a symmetric relation, a non-symmetric, and a non-symmetric relation? What's fundamental about that structure of reasons and below? So that's just to say, sort of open a tab here and in 5 weeks or so, we'll come back and look at a structure like this. Now, what we can say about the two kinds of relations is, we can think about, from the pragmatic side now, there could be a practice in which I produce utterances and you keep score on them. So I say P, and you, in your little book of Bob, you write down P as something I'm committed to, and then later I say Q, and you write that down. Now, the idea of that first reasons for reason relation includes that, if I claim that P, that's not all that you ought to be writing down in your book. You ought to be writing down all the consequences of P, the other things that I've committed myself to. Okay, in the context of the other stuff that's in your notebook, maybe, but there may be some things, well, anybody who's committed to P is committed to Q, donkey, mammal, that's not Bob specific. Semantic, therefore inferential, semantically contentful, therefore inferentially articulated. Yeah, Bob's committed to that, but that's because of his semantic inferentialism, this other thing over here. Not everybody is committed to that. But still, it seems like pragmatically, there's a necessity that your speech act makes some difference. It not just license people to write that claim down, but involve some further commitments. And the thought is, well, that's what implication relations do. And then committing yourself to P also precludes you from entitlement to some other things. It excludes other commitments. So if it excludes R, you write down P and you write down R, and you look at that and you're going to, make an unsmiley face next to that. There's something wrong there. He can't be entitled to both of these. I put in the background reading for this week a wonderful essay of Hugh Price's that makes a pragmatic argument for the necessity of, in effect, incompatibility. He's talking about negation, but he's doing it on the Australian plan that treats incompatibility as more fundamentally basic than negation. I'll endorse that plan next week when we talk about logical things. But he imagines people he's pleased to call positivists who only make claims and don't acknowledge them as incompatible with other claims, because acknowledging the incompatibility would involve a negative attitude towards some claims, and they just embrace claims. They don't reject claims. That's the thought. And he has a little dialogue. Me. Fred is in the kitchen, and sets off for the kitchen. You. Wait, Fred is in the garden. Me. I see, but he's in the kitchen, so I'll go there, and sets off. You lack understanding. The kitchen is entirely Fred-free. Me. Is it really? But Fred's in it, and that's the important thing. And leaves for the kitchen. Now, this is at most an intuition pump, but it's pumping an important intuition that your claim shouldn't just commit you to some other things. It's got to rule out some things too. Or, when I claim that P, you say, well, so what? It only matters for what people keep score of. But if there aren't these relations between that claim and other claims, then it's a wheel that nothing turns on. I mean, this notion of exclusion is the basis of Claude Shannon's definition of information that we use to measure it in terms of bits. But the measurement isn't sort of the conceptual move. He's saying the information content of a signal that's sent from one person to another is the options that the receiver had before the message related to the options that they have after they get the message. And there's information in it if the options they had before, if that set is cut down somehow. Some things are ruled out. If in fact you rule out exactly half of them, that's a bit of information. And Shannon information theory goes on from that. But he's he's codifying in that notion of information an important insight that this dimension of content, which he calls information, consists in the negative difference that making that claim makes, what else it rules out. And Price is here fantasizing about a discursive practice that doesn't involve any information. The claims aren't informative because you can't even convey sort of where Fred is, if one claim about where Fred is compatible with all the other claims about where Fred is. So there's a pragmatic argument for the necessity of incompatibility as a reason relation that I think is parallel to the Simonelli, anyway, bears comparison to the Simonelli pragmatic argument that incompatibility needs to be symmetric. It's prior to that, but corresponding. And we say, well, is it a purely pragmatic matter? Well, it better not be, because we can think about reason relations semantically as well as pragmatically. What would our semantics look like if we didn't have a relation of incompatibility in it? Now, by our semantics, I'm sort of, for our purposes, always can mean the truth maker version, but there's corresponding things we could say of others. What does the truth maker setting look like if it doesn't have incompatibility? Well, that's just dropping the partition of states into possible and impossible ones. The impossible states are the ones that involve exclusion. That's the way we define incompatibility of other states, as if their fusion is impossible. And this is saying, okay, we're not going to distinguish between possible and impossible states. Well, in the truth maker setting, you can do a lot. In fact, neither of Fine's definitions of consequence depend on the modal aspect of the metaphysical universe that provides the semantic interpretance for our claims. His notion of entailment is if all the truth makers of P are also truth makers of Q, then P entails Q. That's just set theoretic inclusions of states, doesn't involve any particular exclusion. His notion of containment, if every state that is a truth maker of the premise is contained in a state that is a truth maker of the conclusion, and every truth maker of the conclusion contains a state that's a truth maker of the premise, then you have consequence in his sense of containment. That appeals to the mereological part-whole relation, but doesn't appeal to the modal one. So he's giving us a setting in which we can make sense of the positivists. They've got consequence in either of those senses, but they don't have incompatibility. We just carve off the modal component of truth maker semantics. Wait, except we can't, because we can't define the relation between truth makers and false makers without that. Remember, I suggested that a minimal condition would be that the set of truth-making states and the set of false-making states must be disjoint. So we could use that sort of weak notion, of set theoretic notion of opposition. But in fact, to do anything like the work that Fine calls on the distinction between truth makers and falsity makers to do, we need a stronger relation. We need to impose a stronger structural constraint on the relation between truth makers and false makers in any proposition. What he calls exclusivity, the inspiration for Ulf's notion of consequence. He says, no, it must be the case that any fusion of truth makers of P with falsity makers of P must be an impossible state. That's exclusivity. So he can't really set up the semantics with truth makers and false makers without the modal component. So it only looks as though you could really just have one of them. It's at any rate baked deep into the truth maker setting that you have both relations of consequence and relations of incompatibility. That's a sort of peculiar argument from it, because we ask, well, why did you build these things in? But at any rate, there's a semantic relation there because we can't distinguish truth makers or false makers unless we can have this stronger notion of exclusivity. That's an acknowledgement on the semantic side that, yes, this fundamental discursive bipolarity between truth and falsity is intimately related to the notion of exclusive, of incompatibility, as well as the notion of implication. When I step back and try and think about this, I think we have two sorts of arguments that are kind of neutral between the pragmatic and particular pragmatic and semantic metavocabularies we've been working with. I've at least waved my hands already at the argument Sellers makes that in order for something to count as a descriptive concept and not just a label, it must be situated in a space of implications. That is, applying it must have consequences. And indeed, subjunctively robust consequences. They must have consequences that come with a range of subjunctive robustness. So Q follows from P, and it would continue to if you threw in any of these additional premises. Maybe not all premises, all additional premises, that would be monotonicity. but it's got to have at least some modal robustness to the implication. That's a point, by the way, that Ryle, in his classic essay, If, So, and Because, argues that any implication has to have a certain kind of generality. So he says, the argument, today is Wednesday, so tomorrow will be Thursday. That's a good argument, but it's good as essentially as an instance of a pattern. It's not just this particular instance that's good. He doesn't give an argument for that. He's describing, it's a sort of ordinary language philosophy, but he's saying you don't talk about following from unless there's this element of generality. And there is, by the way, a fascinating discussion in Peter Abelard, lover of Eloise, the medieval logician and philosopher, who wrote about hic et nunc implications, here and now implications, where I say, look, right now, given all the facts, the way things are, if I were to pull this cord out, it would have a certain effect. But if absolutely anything else, anything were different, that wouldn't follow. It only follows under just these circumstances. And he finds that an ultimately unintelligible notion, using very different, coming from a very different background than the Ryle does. Anyway, I think there is something to this Salarzian thought that at least there's a kind of content that you can't have unless endorsing one of them has consequences for endorsing others. And so no kind of commitment could qualify as doxastic commitment unless it had that kind of content. Beliefs have to have that kind of content. And then second, an argument of the Shannon sort or the Hugh Price sort, that in addition, there's a kind of content that you only have if making this move precludes you from making other moves. Taking this stance precludes you from taking other stances. That it excludes them. Then there's, if you don't have that, you have no information in it. And again, that's another dimension of modally robust content, exclusive rather than inclusive. As I say, it feels to me there ought to be a compelling transcendental argument to be made here, but I confess I don't see how to pull all of that together. And I would find it sort of weak and disappointing if we say, oh, well, when we look at what we mean by doxastic commitment, belief, kind of thing you're expressing an assertion, it at least we observe always has these too. Yeah, but so what? I want to know why it has to be that way. That's the transcendental argument. I think it does have to be that way, and I think the sort of considerations I've been raising provide the reasons for that, but I can't myself articulate those into a compelling argument. I'm just leaving that there for, let's think about this. But that structure, I think, that is the structure of reason relations. There are these two. One of them has to be symmetric. The other one has to be non-symmetric. That much structure there really is. Yeah. Okay. Let me talk about the structure there isn't, or at least that I claim there isn't. When people first started thinking about reasoning in a serious mathematical metavocabulary in the 1920s and 1930s, there was a convergence of thought about reason relations. Well, they really focused just on implication. We have to sort of fill in the story for the other one. Logicians. So Tarski, in his famous groundbreaking article on the concept of logical consequence, gives us three conditions that, not by coincidence, correspond to his Polish colleague Kuratowski's axioms for a topological closure operator. And here I've put these on the handout. There's the principle CO, that's for containment, that says if you have a set of premises gamma and you're looking at the set of consequences of gamma, that's the relation whose structure he's after, then the premises are among the consequences. The consequence set is a superset of the premises. And that seems plausible enough. And then monotonicity, the consequences of gamma are always a subset of the consequences of gamma plus anything. Throw in more stuff, you get more consequences. You don't lose any. That's monotonicity. It's MO. And transitivity, which in this setting is idempotence, that the consequences of gamma are just the consequences of gamma. Once you've extracted the consequences, you got all of them. Now, Tarski's working in algebraic topological, or basically a model theoretic setting, but independently inventing proof theory. Gensen has the same rules. Containment, gamma together with any A always implies A. Doesn't matter what the context of that is. If gamma implies B, then gamma plus any A also implies B. And now this really is the CT, the cumulative transitivity. If gamma implies A, and gamma together with A implies B, then gamma already implies B. And you can show that these define the same structure, and it's the familiar closure structure. Let's just close under consequence, and that makes sense as long as these conditions hold. And Tarski was right about logical consequence. He's right about the kind of consequence that's used in mathematical argumentation. In the essay, he fascinatingly slips back and forth between talking as he ought officially about logical consequence, but more than half of the time, he just says consequence. He isn't distinguishing between those. Might be just his interests, but in fact, he thought consequence was logical consequence. I'll talk about that ideology at the beginning some next time. But the claim I want to make is non-logical inferences, material inferences, aren't in general monotonic. Some of them are, say donkey to mammal. That's any more you know about Pedro, besides knowing that he's a donkey, isn't going to infirm the consequence that he's a mammal. I want to say, even if you tell me, oh, and by the way, Pedro's only exists in my imagination, well, then a mammal exists in your imagination too. You can. So some of them are monotonic, and those are really important. Those are places to cling to in a storm. If you got one of those, you sort of know what's what. But lots of consequences or implications in ordinary life aren't like that. And they can't all be like that, I want to say. It's impossible to speak an empirical language, all the consequences of which are monotonic. So, I mean, the sorts of examples that people use, Tweety's a bird, it follows Tweety can fly. And you say, well, not if he's a penguin. You say, that's right. From Tweety's a bird and Tweety's a penguin, it doesn't fly. So, well, then shouldn't you have said, if Tweety's a bird and Tweety isn't a penguin, then, well, yes, but what else need you to say? Say maybe Tweety was a moa, maybe he was some other flightless bird. You can put in qualifications, but think about consequences in everyday life. I say there's some cookies in the cupboard, and you infer, you draw the consequence that you can get a cookie out of the cupboard if you want one, but of course not if the door's nailed shut or has been mined or infested with insects. There are all sorts of ways in which that consequence could be bad. Well, you say, so that's good enough for ordinary reasoning, but if we're being careful, then we don't say, therefore, we put in the qualifications. Well, what if there's too many qualifications? This was a sort of issue that came up when people were trying to get computers to do ordinary reasoning. In one of the early script languages, man goes into the restaurant, sits down, orders a hamburger. They bring him the hamburger and he refuses to pay. Why would he refuse to pay? Well, what are the reasons? I mean, maybe it was burned, there's rodents in it. What if it were encased in glass? What if it had explosives in it? What if they brought it to him in a railroad car and it weighed 2,000 pounds? Well, what are the ways in which that expectation that if he ordered the hamburger and they brought it to him that he would pay, what are the number of ways? What are the various ways in which that could fail to be true? What are the diffeasors for that? Maybe there's an infinite number of them, but more worrisomely, there might be an indefinite set of them. It might be unspecifiable what all the ways in which that implication could go wrong are. And in fact, people came to realize that there are Hlobil sequences, S-O-B-E-L, where you flip the value of an implication by adding a new premise. I say, well, yeah, I can light that candle because I can strike this match. And then says, well, not if it's a defective match. Say, okay, well, if I strike this well-made match, well, not if it's wet. Okay, if I strike this dry, well-made match, it will light. Yes, but not if it were in a sufficiently strong magnetic field. It wouldn't. That would infirm the inference. But if we add, but inside that magnetic field, it's in a Faraday cage. Oh, well, now that's okay. Now we've got a good implication. Well, not if the oxygen has been removed from the room. If it's in a vacuum, that's not okay. Then it's not going to be a good inference. Well, it will if it's one of our underwater matches that supplies its own oxygen. Well, yes, that's true, unless the compound in that has decayed because, well, a Hlobil sequence is where at each stage you think of some condition that would flip the validity of the implication. And if you think about places where we institutionalize giving and asking for reasons, in law courts, for instance, it's very rare to have a bit of evidence that is dispositive relative to the case before the court. If it's dispositive, if you've settled that, then you've settled the verdict. There is no legal room for another decision. But almost all considerations are merely probative, just to use the jurisprudential vocabulary. That is, it provides some reason, but maybe there are countervailing reasons for it. In medical diagnosis, the patient has a fever, so she probably has an infection, unless the fever is endogenous, because every episode of House that you've ever seen depends on this non-monotonicity. And they discover the next thing and it's completely different. And even physics is no exception. This is observing the non-monotonicity of reasoning from physical principles is the basic theme of Nancy Cartwright's wonderful book, Why the Laws of Physics Lie. And Mark Wilson has investigated the fine structure, if I can put it that way, of the non-monotonicity of many of these inferences. Well, okay, so it seems we need some mechanism for rectifying this situation. If we're careful, we'll use ceteris paribus clauses. I say, there's cookies in the cupboard. So ceteris paribus, you can get a cookie there if you want one. That is indeed what a conscientious person should do. But what do you think the function of that ceteris paribus clause is? If it's turning a non-monotonic inference into a monotonic one, it can only be doing that by quantifying over all of the possible diffeasors and saying, unless one of those diffeasors holds. One of those diffeasors that we may not be able to list all of as we get out into more and more outre possibilities. Well, but if you're really quantifying over all the possible diffusers, what you're saying is this follows unless this is one of the cases where it doesn't. But that's not a substantive or an interesting claim. If you're thinking of the ceteris paribus clause as turning that non-monotonic consequence into a non-trivial monotonic one, the name for a Latin phrase, the utterance of which can have that effect, is magic spell. Chant ceteris paribus, and this magical thing happens. In fact, I claim, the function of ceteris paribus clauses is not per impossibile to turn non-monotonic into monotonic consequences. It's just to acknowledge the non-monotonicity. It's to say this is a consequence. I'm giving you a reason for this, but I'm acknowledging that there can be counter reasons, that you can challenge this and undercut it. But going through that is a messy retail business. It's not something we can avoid at the wholesale level by invoking ceteris paribus clauses. I mean, I'll mention, just to put to one side, you might think, oh, well, that's why we careful people talk about probabilities and credences and so on. That doesn't help, because the same phenomenon occurs in assignments of probabilities. It comes up most strikingly at the level of reference classes. You can get the equivalent of Hlobil sequences for the reference classes you use to determine probabilities. An example I've used for other reasons elsewhere is if I'm looking in good light at a barn in front of me and I say there's a barn, suppose I'm right, but am I justified in making that claim? Does it follow from the situation? Perceptually, it looks like a barn to me. Does it follow that it is a barn? Well, suppose I'm in Barn Facade County, where the local hobby is making trompe-l'oeil barn facades that look like barns but are not really barns. And it turns out that there's 99 facades for every real barn in the county. Then you would say, well, it doesn't follow from it looking like a barn to me that it's a barn. But I'm also in the state, and no one else in the state builds barn facades. So if all you know is that I'm in this state and I see what appears to be a barn, then odds are overwhelming that it really is a barn. But if you move out to a larger group, it turns out the hobby has spread and so on. It depends on what your reference class is, and that's not a natural fact about you as you stand sort of looking at the barn. Anyway, what the right reference class is. So I put probabilities to one side. I'll say parenthetically, we inferentialists think it's remarkable that thinking in terms of probability is as effective as it is, because what they're doing, from our point of view, is taking a complex algebraic structure of reason relations and projecting all of it onto the real line, onto a segment of the real line, and saying we're just going to use these numbers that we associate with it as the semantic interpretants and manipulate them instead of the concepts. And you're throwing away basically all the semantic information from our point of view. So it's really remarkable that actually Bayesianism gets a grip on codifying some of our reasoning. But we're after the real thing here, the complicated structure of the reason relations. And if we think about this, again, this non-monotonicity, why does it have to be that way? Well, I think it's just a consequence of the fact that we need to be able to finitely state reasons. You can only say so much. And however much you say, there's defeasors to it that have to be acknowledged. You could always say more, but at any rate, ordinary reasoning, I claim, is by no means always monotonic, and in fact hardly ever is. It's rare and precious when we can precipitate out a monotonic set of implications, because those are guaranteed to have the consequences that they have. Yeah, John.
Isn't the reference problem a problem for the framework we're working into, the non-probabilistic framework? I guess I'm thinking, take the Barnes-County case. There's going to be some fact in the matter as to whether, given you have all the information you said about Barnes-County, whether your perceptual experiences of something seeming to be a barn in front of you is a reason to think there's a barn in front of you. I think that that requires us to make a decision about what the reference class is, even in the non-probabilistic framework.
I'm not sure how you're carrying that over to the non-probabilistic case.
Yeah. The way I'm thinking is, that people create these barn facades in Barnes-County, but you also know that in the rest of the state there are.
I see. If we just think of those as claims, absolutely. I mean, our picture is that this is just the way things work. That you make a claim that is defeasible, and that's on something like the assumption that none of the defeasors are in play. And if somebody says, well, what about this? That's a challenge, because it's saying, no, this isn't one of the circumstances where that actually follows. And you've got to come back with something that either says the defeasor isn't true or adds a further premise, takes the next step in a Hlobil sequence to reinstate it. We see this complicated structure where you can think of the points as being premise sets, and they come with their sort of cloud of consequences, and any new claim sort of moves you from one premise set to another, and the set of consequences can expand or contract arbitrarily if we're just looking abstractly at it. And so it is, in a way, remarkable that we can navigate as well as we do in that complicated space. But we do associate with each sort of implication. We have a rough or ready sense of whether it's a good one or a bad one. Is it the case that if the lioness were to notice the wounded wildebeest, the hungry lioness would chase it? And we say, oh, yeah, that seems like a materially good implication, though there are lots that I wouldn't have a view about whether they were good or bad. That's one I know enough about lions to be confident of. And I come with a fallible and incomplete but still important sense of the range of subjunctive robustness of that. So I say, well, not if the lion is struck by lightning, but yes, if that beetle on the bark of the tamarind tree 2 miles away were 2 inches farther up the bark, that wouldn't make any difference. It's being a Tuesday or a Wednesday doesn't. Well, unless the hunters only come out on Wednesdays, and so on. We have a rough or ready sense of the range of subjunctive robustness of that implication. And that's the complicated structure we're navigating in. So, yeah, that's exactly analogous to the relativity to reference class. But that was the point I wanted to make, that you don't avoid that problem by invoking probabilities. Yeah.
I wonder if I might ask you a question about, you mentioned that the fact that this kind of complicated conceptual map that inferentialism pictures produces apparently quite well to prove probabilities. You mentioned that this is kind of remarkable or surprising from an inferentialist point of view. I wonder if do you have an account of what explains this apparently very surprising reducibility, which you might also think powers contemporary large language models. Exactly this kind of thing.
I'm no less surprised that they can do what they can do, and no less confident that they're climbing a tree that's higher than I thought it was, but I'm really sure you can't get to the moon that way. But no, I can't. I can't explain the unreasonable efficacy of some of these approximations. Let me mention, though this is almost universally ignored by people thinking about non-monotonicity in the context of non-monotonic logics, that non-monotonicity applies equally to incompatibility. That Tweety being a bird and Tweety being a non-flyer are incompatible, but not if Tweety's a penguin. We can recover that information. We ought to worry about the non-monotonicity of incompatibility as well as the non-monotonicity of implication. And this matters because, as I say, that various programs in non-monotonic logic exclusively address consequence, and some of them use methods that presuppose the monotonicity of incompatibility. So all the default approaches to non-monotonic reasoning that say about the Tweety case, look, there's a default presumption that, but it's a rebuttable default presumption that birds can fly, and we need to move around in the space with that. Most sophisticated working out of that is by Ph.D. John Horty. That's a default approaches to non-monotonic logic. Use the inconsistency of a constellation of commitments that you end up with as their measure for when you have cycled out of bounds and need to adjust your parameters, and that's assuming classical negation, and so the non-monotonicity of assuming the monotonicity of incompatibility. That is that if gamma is an incoherent set, then you can't cure that by throwing anything else in. And we have cases where how is that? An instance, I guess that case goes the other way, but I was thinking of there being the situation where there was no observation that could settle between relational and absolute theories of space at Newton and Leibniz's time, but once you add electromagnetic theory, then you can distinguish them empirically, but that isn't an instance of this particular phenomenon. At any rate, the only reason there is to think that material implication must be monotonic, I think, is that the only model we have of consequence is logical consequence, and it's monotonic. So, and that's why people say, well, then let's get a non-monotonic logic. Well, the other thing you could do is get a logic of non-monotonic consequence relations, and that's a different thing. And as we'll see next week, it turns out you can get a monotonic logic of non-monotonic consequence relations. I guess I don't want to take the time to go through this, but you'll see at the bottom of page 1 and over onto page 2, I mentioned an argument, actually also due to Ryan Simonelli, that he's providing a recipe for turning failures of monotonicity into failures of transitivity. Those two, if we're going to treat material reason relations as not satisfying monotonicity, we're going to have to treat them as not being de jure or globally transitive as well.
So in this example of the failure of transitivity, or I guess in the example of the failure of monotonicity as well, is this sequence tweet is a bird implies tweet flies, and under the bilateralist interpretation, we're saying that it's out of bounds to assert tweet is a bird and deny tweet flies. Now, it's not always the case that it's out of bounds to do that, because if we assert tweet is a bird, tweet is a penguin, and deny that tweet flies, that's not out of bounds. So it seems like when we're saying that in this bilateralist interpretation, something is out of bounds, we're saying that it's out of bounds and those are the only things you're ever asserting. Is that right?
In order to apply the bilateralist interpretation to the non-monotonic cases, you have to think this is your whole position. And the question is that in bounds or out of bounds? Now, I mean, this does raise a difficulty. Nobody could be in that position of only accepting Tweety as a bird. I mean, that might be really important to you and you go around saying it all the time, but it cannot be the only claim that you accept. So, how are we thinking about that bilateralist claim that accepting this and only this while rejecting the conclusion is an out-of-bounds position? It's not anybody's actual position. And, I mean, that is something that needs to be addressed in the pragmatic story of how the reason relations, once we've got them all, once we know how to talk about those, normatively govern moving entitlements around, changing attributions of entitlement by challenging and defending claims. So once we have all the apparatus on board, I think we can give a satisfying answer to that. But you're right, it has immediate consequences for how we think about what a position is. And,
Can we think about positions just as the totality of everything you accept and reject at a time?
Well, those are positions, but if we're going to get Tweety and Tweety's a bird and Tweety flies in there must be positions that are not potentially everything that is accepted or rejected.
Well, we could consider this a hypothetical agent. It seems fine for us to have positions that no one in fact is ever going to take on.
Yeah, but is there even a hypothetical agent who only accepts that Tweety is a bird?
Right. I see what it is.
That's the concern. I mean, some kind of supposition, I think, is what one needs to think about, and it's the same one when we're assessing ranges of subjunctive robustness. Okay. So I want to say, I think in the end this is not that controversial, that material reason relations aren't in general monotonic or transitive. That's going to have consequences for how you think about the relation between logic and reasons. That's what we're going to talk about next time. It would be hasty to just conclude, well, so logic has nothing to do with reasons. But it is not hasty to conclude, well, the notion of reason is broader than the notion of logical reason. Okay. I said the fallback position of people who think about these issues in the context of non-monotonic logic is, okay, at least we can count on the structure of cautious monotonicity. That although the implication of A by gamma may be defeasible by adding B to the premise set, that doesn't happen if gamma already implies B. That is, none of the defeasors of the implication are also consequences of the premise set. And there's a weakening of the transitivity condition that I think doesn't matter, and I don't want to go into in the broad sense. In the topological sense, you can mix the contexts and you get a weaker claim, the cautious transitivity they put here, if you insist on the same context, the gamma be the same. We can just, that matters in some context, but it doesn't really matter to us. So the first thing to point out is that, and this is number 7 on page 2, that cautious monotonicity and cumulative transitivity, the fallback positions, are duals. They're just rearrangements of the same 3 sequence. And here's a way to understand that. So suppose I say gamma implies A. By the way, the turnstile we use with the squiggle, we call it the snake turnstile. That's meant to acknowledge that it may be non-monotonic. It's not a Hilbertian one. But so if I say gamma implies A, and then throw B in as a additional premise, which is also implied by gamma. Cautious monotonicity says you won't lose the consequence of A by throwing in this new thing. And cumulative transitivity says, yeah, and you don't get any new ones either. If you could get A from gamma together with B, where gamma already implied B, then gamma already implied A. So you don't gain any consequences by taking that as a premise either. So here's a way of thinking about it. Suppose the premise set gamma implies A. The explicit content of the premise set is just the premises that are in it set theoretically. That's the content. The explicit content of it is just that set of premises. But if gamma implies A, you can say that A is implicitly contained in that set. Is part of the implicit content in the sense that it's literally implied by that set of premises. It's implicit in the sense of being implied by. It's consequentially or implicationally implicit. That's a definite thing to mean by implicitly contains. A premise set explicitly, literally contains its elements, but implicitly contains its consequences. And then we can see that what we're talking about is the effect of explicitation. That is, taking something that's part of the implicit content of a set of premises, in this literal sense that's implied by, and making it explicit by adding it to the premises. That's explicitation, is making explicit something that was implicit. But now I'm giving this a specific sense relative to an implicational statement. And notice that this notion of implicit content is not a psychological notion, because it's a matter of what actually follows. And it's not a logical notion, because I haven't talked about any logical vocabulary. There's no conditionals or negation or anything in there. I'm using the sort of meta language we used to talk about logic. There's the snake turnstile in there. But this is just intrinsic to the implication relation, that a thing you can do is see that the premises that you explicitly acknowledge imply something else, and so you respond to that rational relation by acknowledging explicitly commitment to that consequence. You add it to your premise set. Now, that's a paradigmatically rational act to do that, to acknowledge the rational consequences of your premises. And what cautious monotonicity says is doing that never loses any implicit content. And what cumulative transitivity says is explicitation never gains any implicit content. You never get any new consequences by merely adding explicitly to your premises something that was already implied by them. Together, the conjunction of this softened monotonicity and softened transitivity, the conjunction of them entails that explicitation is inconsequential. It doesn't make any difference to the consequences. So you've got some gamma, and as long as you're rationally explicitating, just adding to your premise set things that are already a consequence of it, that's never going to change what follows from the premise set. You don't add anything, and you don't lose anything. And I want to say that's false for material reason relations. Explicitation is not inconsequential. Explicitation, that paradigmatically rational operation, can sometimes add new consequences, and it can sometimes subtract consequences. So, if I can make that out, the conclusion will be that material reason relations don't even exhibit that structure, the structure of CM and CT. So if, for instance, we want to be able to logically codify ordinary reasoning, we can't assume that the implications that we're codifying meet this minimal condition. Okay, this isn't a perfect time in my story for us to stop for the break, but if I wait much longer, we're not going to do it. When we come back, I'll give you an argument for that claim that explicitation is not, in general, inconsequential. It's 2:30. Let's come back at 2:45. I mean, I just found myself saying that I thought the two kinds of reason relation need to be thought of as independent of one another. I didn't mention the connection between them that is something like the original sin of traditional logic, because the connection between incompatibility and implication in traditional logic, intuitionism every bit as much as classical logic, is explosion. everything follows from a contradiction. And if you take that principle away, for instance, in relevance logic, where you don't have that egregious way of connecting incompatibility or incoherence and implication, if you take that away, you basically can't tell in relevance logic the difference between inconsistent sets and consistent ones. You can reason with both kinds. They have some consequences, but not everything is a consequence. So, though this isn't a place where the relevance logicians go, we will. It's not the end of the world if you find yourself with inconsistent beliefs. It's important that you not explicitate them. If you do, you end up with a contradiction and it logically blows up. But as long as you leave the contradiction implicit, you can work perfectly well. Even you can explicitate either one of them, just not the other one, and hope to fix things up on down the line so that you can either not have it as a consequence anymore, or you can now embrace it without. Okay, so where I'd gotten to was the important conceptual point is a way of thinking about implication that underwrites the notion of explicitation. That is, that when you say gamma implies A, and think about the content of gamma, you can distinguish between its explicit content, what are the premises that are elements of that set, and its implicit content, what is implicit in the sense of implied by. So A is part of the implicit content of gamma in that case, whereas the elements of gamma are its explicit content. And explicitation is now looking at comparing the consequences of gamma and the consequences of gamma together with A. Gamma together with A is what the result of explicitating the consequence A, adding it to your premise set. And CM and CT together, those structural principles, plausible though they are, together entail that explicitation is inconsequential. That's the slogan, that it doesn't change what the consequences of the set are. Doesn't add, that's CT, doesn't subtract, that's CM. And I just gotten to the point of saying, well, I wanted to argue that even that isn't so. So here's a way to think about it. Think of your premises as a database. And the database is from a universe of possible databases in whatever language it's written in, but you've got some set of claims. They're logically atomic. We can just use sentences for them. But let me mention, I'm talking about databases. That's compatible with them having, arbitrary internal complexity as long as it isn't logical complexity. So they can be structured records of sort of arbitrary types. They're just at the level of abstraction. We're looking at them. They're just different from one another. We can tell what they are. So you have a database, that's your set of premises, and standing in for our turnstile, the implication relation, is going to be any inference engine. Could just be any theory that you clamp onto that in order to extract consequences from it. The consequences of this are the result of applying the inference engine to the database. And you might have a query language that goes in and asks whether this thing is a consequence of the database. So standard sort of setup. And now we say what corresponds to explicitation in this model of implication relations, so database plus inference engine model, is any consequence that follows from the data given that theory or inference engine. And now what happens if we add that to the data? And if CM and CT hold of arbitrary inference engines, then it ought to be that that makes no difference, is inconsequential for what the consequences are. Okay, but suppose the database we've got is a set of observations, empirical observations. Say it's the output of the CERN supercollider, and we put all the measurements we've made into the database. And our inference engine is a theory that lets us extract consequences from that. Say it's the standard model of subatomic particle physics. We use that, and we have what's implicit in this data is whatever follows given the standard model from these observations. And now we ask, well, if one of those consequences is moved over into the database, we observe one of the consequences, and now it's part of our data. CM and CT say, that's inconsequential. You can't learn anything that way. Nothing new will follow from that, and no conclusion that you drew from that before will be infirmed. And that's just false. When you confirm empirically the result of applying your theory to your data, and you actually get that result, that confirms the theory and or not. I mean, depends on how it's related. But observing that supermassive particle, the weakly interacting massive particle that confirmed the theory, that was huge, a huge intellectual achievement. And in general, testing your theory is explicitating those consequences, well, seeking to. If the database is the observation, it's observationally confirming or disconfirming the consequences of your theory. And that's, in fact, how our theories change. You know, I talked about medical diagnosis. I talked about how things were in a law court, where you have the data is the fact specified in a non-legal vocabulary. In fact, explicitation can make all the difference in these material cases. And I think thinking of the database plus inference engines, where the inference engine can just be a theory, shows that that's true. We're not going through a useless exercise, an inconsequential exercise. It can actually change what consequences we draw. At least we would like to be able to handle reason with reason relations that were like that, where applying the inference engine and explicitating the results of that can substantively change what follows from the resulting set. So inference engine plus database, medical diagnosis, jurisprudential argumentation. I think in all of those cases, in the jurisprudential case, you have a theory of the case. You have these facts. According to the theory, you get this consequence. Well, if you're allowed to treat that as a fact, that changes the situation in the courtroom, changes the status of the consequences that you have. Indeed, there's a distinctive kind of intellectual progress that's made precisely by rigorously thinking through the consequences of your current commitments. And I think in the history of science, in the history of philosophy, we find that doing that changes what we take to follow from, it's not this, what follows from gamma so much as what follows from gamma in relation to its explicitations, to gamma plus A, to gamma plus A and B, and so on. What we're doing is comparing the consequence classes of these premise sets that are related to one another as explicitations one of another. But if that's so, if explicitation is not guaranteed in advance to be inconsequential, then the notion of extracting all the consequences of a claim becomes ill-defined. I can extract some of the consequences, and that gets me to a premise set that has different consequences than the original one. Some of the original consequences may still not be there. Some new ones that were not consequences of the original set can come in. I might get to sequentially add all of the original consequences of gamma, and if I do that in a different order, I may get to different places. And those different places are not only different from each other, but they're different from what I would get if I took, if I explicitated all the consequences of gamma to begin with. Did that, not one by one, but did the whole set. If the structure of material reason relations really is hyper non-monotonic, even CM doesn't hold in it. There's nothing privileged about the consequences of gamma plus all the consequences of gamma. That's one place you can get to from gamma by explicitation, but it may not even be the largest set that you get. It doesn't include some things that you can get to if you explicitate along the way. Never mind if I explicitate gamma by adding theta to it, where every element of theta is implied by gamma. Not sure what point I was after there. Explicitation in this substructural setting becomes path-dependent. The scientific term for that is hysteresis. It matters what order you add these things in. Yes, I'm sorry. The other point was, so one form of explicitation path is we're restricted to the consequences of gamma. That's a well-defined set. And we're looking at all the things you can get as consequences by taking some subset of those consequences of gamma and adding them to gamma. But another way to explicitate, suppose that A and B are both consequences of gamma. I add them in, I get gamma AB, and now something C that wasn't a consequence of gamma becomes a consequence of gamma. Instead of just adding in explicitating consequences of gamma, I might explicitate consequences of gamma together with A and B. That is, explicitate C, which was not a consequence of gamma. Now that's going to take me to a completely different place than you could get to just by adding to gamma subsets of its consequence. If you don't have the closure structure, not now topological closure, but explicitation closure, which is CT and CM, weaker than the topological conditions MO and transitivity, weaker conditions than that. But explicitation closure, as long as explicitation is inconsequential, the notion of all of gamma's consequences makes perfect sense. But as soon as we drop that requirement, it doesn't. And that means that for any reasoning any reasoning that's normatively governed by reason relations that are substructural in the sense that they're not even explicitation closed, the notion of the rational consequences of some set of beliefs is just ill-defined. There's a whole lot of things you can get to by just explicitating. And there's no privileging one of those over the other from a structural point of view, as the consequences, or where you ought to get. Now, I think if we actually look at the history of science and philosophy, we'll see instances of this. Imre Lakatosh's discussion in the second half of his book Conjectures and Refutations, on the development of the concept of a polygon in 19th century science is a paradigm of this, where people were just extracting consequences from the definitions that they had, and they were finding all of these new things. The Weierstrass monster, it's a polygon that is continuous and nowhere differentiable. It's a terrible monster of a thing that wasn't supposed to be a polygon by their definitions, but ended up being so. So, as I mentioned at the beginning in the sort of advertisement for the claim, philosophers are used to using the notion of the rational closure of a set of beliefs or of a theory without thinking very much about it. Of course, it makes sense to talk about what else you're rationally committed to, everything that you're rationally committed to, the set of things that you are rationally committed to by this set of premises. And what we see in the substructural cases, there are all kinds of things you can mean by that, because there are all kinds of places you can get to by explicitation. I mentioned one structural difference between them. The explicitation paths that you get by only adding consequences of the original core, the gamma that you started with, versus the paths you can get to if any new consequences come up by explicitation, by adding consequences of gamma. If any new things come up that weren't consequences of gamma, but are consequences of gamma plus A plus B and so on that were consequences, and now you explicitate that, that's a different sense of rationally accessible from than if you require that you only look at the consequences of gamma. So I suspect that there are all kinds of interesting phenomena to discover in these explicitation paths. And that's what this program is written to let us explore, because I don't even have sort of conjectures about what interesting things might come up here. I just want to look at a lot of them and see if anything sort of comes out of it. But to have a test bench to investigate it if something interesting does come up. So yeah, Ned, would you hook up and let's look at this.
It's on the pad, oh yeah.
And we're looking at really small languages of like 5 and 6 sentences. Because if you just take reason relations as sets of pairs of sets of sentences, the ones that stand in an implication relation or an incompatibility relation, with minimal, with the minimal structural constraints on them, then you get something like this. So the way to read this is we've numbered the propositions in the language. This one has all of 5. And we're looking at premise sets that start with nothing over on the left, and then the singletons in the leftmost column, the doubletons, tripletons, and so on as the premise sets. And we've imposed a set of reason relations on this. So for instance, some of those premise sets are incoherent. That is, the 0, 2 there, it's red. The coherent ones are in green. That just means that 0 and 2 are incompatible with one another. And we've imposed a set of reason relations that meets very minimal conditions. And this is just an arbitrary one of those. In a minute, we'll look at a different one. And here we've picked, okay, suppose we've got the premise set 0, 2. That's incoherent itself, but among its consequence sets, the ones that are, well, its consequence set here is 0, 2, and 4. So 4 is a consequence of it. Gee, that set is coherent in here. It turns out that adding 4 was just what you needed to get something coherent, even though 4 was already implied. We could say 0, 2 was explicitly incoherent, but implicitly coherent. I mean, one isn't so much surprised about it being the other way around. The premise set looks fine, but you start extracting consequences. You see it is implicitly incoherent, but actually that notion of implicitly incoherent also ramifies. Does that mean that some explicitation route takes you to an incoherent set? Is it enough that there is some way you could get to an incoherent set for it to be implicitly incoherent? In this case, once you've cured the incoherence by explicitating the 4, after that, continuing to do that, well, let's see, we look at the consequences of 0, 2, 4, and now we're not getting those by explicitating that set. Those are just the consequences of it. But we can then explicitate with those consequences. That's what it will take us to the far right. Ultimately, it's, as far as you can go, takes you to an incoherent set. So you sort of pass through coherence along the way. Push the purple button up there. Did that make no difference?
I think because it's already explicitated all the way across.
Yeah, why don't you
If we
try
go back.
2, 3 up there. Start just,
And there it's
okay. Oh,
that's if I have
right. And that's just looking at the consequences of 2, 3, 4, not the consequences you can get to by explicitation. So we've got these the lines are just the consequences. And now we're tracing explicitations relative to those consequences. Okay, why don't we go all the way up to 6? Let's start over and get a 6-sentence language. I mean, we can actually do larger ones, but they graphically quickly become that you can't see anything in them. And in a proper version, you'd be able to expand, magnify part of it so you can work with those. And I should say this is using the guts of a program that was written to, you can just use a test MSF for that in the same parameters we had before.
I think if we'll have to go through the parameters, so we'll just do 6 sentences, 0.3 implications.
I'd say just leave it random.
Random on that as well.
No, make that,
Get too high.
yeah, make that 0.2 and 0.4 and 0.4.
And if we do 10, my computer will catch fire.
Okay, so maybe look at just 2, 3. Okay, so before you clicked on that, can I go back outside of it? If you hover over it, you can see its consequence set in blue, and then if you click on it, you'll get the sets you can get by explicitating some things from that consequence set. So this is the first set of explicitation things. And here, everything stays coherent. This is a good place to be. It's explicitly coherent. It's implicitly coherent by any standard. If we show all the explicitation paths on it, this is now allowing those things to explicitate from their consequence sets. So undo that button and now just hover over 0, 2, 3 here. And we see its consequence set is the whole language, which is we stipulate, okay, now all the paths, which we stipulate is incoherent. And it turns out that you can get to lots of other places if you're allowed to add the new stuff that wasn't in the original consequence set. But mind you, what this is supposed to be modeling is this paradigmatically rational activity of your thinking about what the consequences of your commitments are and explicitly acknowledging them, saying, okay, now this, I acknowledge that I'm committed to this too. That's what reasoning is. I mean, you can also reason and decide, oh no, apparently I shouldn't have been committed to all of those, but this is a paradigmatic kind of reasoning. And just structurally, the options, it's much more complicated than the way philosophers have thought about it. It seems to me a sort of brave new world here. Yeah. I don't know. Questions about what this does? We're going to try and put an executable version of this up on the website so that you can play with it if you like.
I've actually I did it.
Oh, okay.
Yeah, so
okay, thank you. Well, I need to put it up on the website so people can get it. I mean, I was going to put the Python program up, but the trouble is it calls on these other programs. But let me just describe the other one. Was the dialogic pragmatics, which randomly picked a bunch of reason relations subject to some constraints I'll talk about in a minute, and then had two interlocutors make a claim, make a challenge to that claim according to those reason relations, make a defense of it, run those dialogues out to see sort of, could we tell anything about which starting points ended up at the same conclusions? What difference did it make to the question of whether the original claimer ended up entitled to the claim that they had if we fiddled in various ways with the reason relations? So trying to look at the model the actual dialogues that you would get of giving and asking for reasons using these reason relations. I mean, I say, so we would like to mimic natural languages, even with some minimal vocabulary. It's still going to be a lot more sentences than this. But the sorts of things you need to know to fix reason relations, well, if you took all the sentences in nautical vocabulary, say, about sloops and mizzenmasts and helms and so on, and took arbitrary sets of those, what percentage of them are incompatible? What percentage of them stand in an implication relation? I mean, even approximately, is it that 1 out of 10 or 9 out of 10 of the subsets would end up being incompatible with one another? It's really hard to know how to think about that. How would one approach this? I mean, the Sicily lab at Stanford has this wonderful database that has 750,000 single premise inferences. Anyway, it's pairs of sentences, and they enslaved people on TaskRabbit to say, of these two sentences, does one imply the other? Are they incompatible with one another, or are they irrelevant to each other? And we have that database. It's only looking at single sentence comparisons. And we haven't been through that to see, but unfortunately it isn't drawn from some particular vocabulary. It's just like the sentences that came up for them. So there's no single topic to it or whatever. It's not clear what you would learn from just doing statistics on that. At any rate, since I think this is the semantic core, that is these reason relations that do this, is the semantic core of meaning, of reasoning, we'd like to know things like, well, in English, what's the probability that two sets of sentences chosen at random would be incompatible? Or that given a set of sentences and a sentence at random, that it would be a consequence, that the sentence would be a consequence of that set. I don't really know how to approach that question empirically. But for philosophers, if our job is, as my teacher David Lewis memorably said, to lay down a set of premises defined as clearly as you possibly can and extract consequences from them as rigorously as you can, and then endorse a different set of premises, extract their consequences, and then do it again and learn your way around by seeing the overlaps, which things can you get to in these different ways. I mean, this was the young Lewis. Later on, he got very committed to a particular set of premises. Okay, rigorously extracting those consequences. But his picture of sort of philosophical understanding as these overlapping paths being once you sort of learned your way around, well, these reason relations are supposed to be the structure of those inferential relations, and this paradigmatically rational activity of acknowledging the consequences of what you believe is a much richer enterprise than it is on the classical picture. It's not settled in advance where you get to, just from the starting point that you have. I mean, where you can get to is settled in advance, but not where you will get to by doing that. And there's even different senses of accessibility. And let me remind you that we care a lot about the notion of a set of premises that look like they're coherent, but when you start extracting the consequences and adding them, you see, no, you get to incompatible things by that. So, bad problem here. That notion of implicitly incoherent, well, we see on here, there's at least a half a dozen sort of interesting competitor notions that you could have for senses in which you could be implicitly incoherent or implicitly coherent. We're going to need a different botanization of them. Yeah, John.
So we've been talking about paths we can get to by explicitating. And I guess I was finding this talk about paths kind of funny for this reason. When we say we have gamma sneak turnstile A, what we're saying is that it's out of bounds to accept gamma and reject A. Now, we haven't said that there's anything particularly good about accepting A. We've just said there's something bad about rejecting it. And now it seems odd to consider paths where we're going to add A to the things we accept. It seems like we haven't said that there's anything special about adding A as opposed to adding any other sign.
I mean, I snuck a rabbit into the hat when doing the pragmatics in trying to say why, to justify the bilateral reading of the turnstile. When we think about implication, the natural way to think about it is, well, if you're committed to gamma, then you're committed to A. There's commitment-preserving inferences, and maybe there's other kinds, entitlement-preserving inferences, and so on, evidence-preserving inferences. But intuitively, we want to say, if gamma implies A, it's not just that you shouldn't deny or reject A, it's giving you some positive reason to accept it, because what are the options? Well, that option of rejecting it is ruled out. So the only option standing, well, you can not take a view of it, or you can accept it. Well, that's a thing to mean by you're implicitly committed to accept it. If you're precluded from entitlement to reject, that's a good thing to mean by implicitly committed to accept. It's not the same as explicitly committed to accept, but it's a good thing to mean by implicitly. So that's the sense that we're appealing to in explicitation, that because being a consequence means that claim, given that you've accepted the premises, you're precluded from entitlement to reject, so you're implicitly committed to accept it, so now you rationally accept your implicit, acknowledge your implicit commitment. And then you do it again, and that's the move from one premise set to another. And what we're thinking about here is the items that we're, in a certain sense, interpreting are sets of sentences, and we're interpreting them by what's a consequence of them and what's incompatible with them. So if you think of the sets of sentences as points in space, then you can think of their relation to the ones that are consequences or are incompatible as sort of the semantogenic relations, the ones that determine the meaning of that claim. That's the space you're exploring when you follow out these different paths. So what we'd really like is some mathematical technique that would give us a grip on generalized reason relations, material reason relations that don't satisfy either of the kinds of closure closure structures that aren't closed in the topological sense, in which logical consequence is, and aren't even explicitation closed, in the sense that CM and CT hold so that explicitation is inconsequential. That's a kind of closure technique, a kind of closure condition. The one I'm suggesting is more interesting and important than the topological one, even though it's not been studied at all. But what we'd like is some technique for studying reason relations, making them explicit, some meta vocabulary that we have formal control over, for talking about radically substructural reason relations. Not a non-monotonic logic, but a logic for making explicit non-monotonic, indeed hyper-non-monotonic reason relations. And that's what I'll present next week. It turns out that you can do that with classical logic, which itself is monotonic and transitive and topologically closed. Well, with classical logic's disreputable twin brother. That is, if I ask what you mean by classical logic, and you can give me an axiomatization of it, but there are lots of axiomatizations of it, lots of formulations of it, say in the sequent calculus, which is to proof theory what the truth makers is to model theory. It's the latest and the greatest. You can do that, and these are all equivalent specifications of consequence and incompatibility relations. Well, they're all equivalent under topological closure structural conditions. But if you drop any of those conditions, sets of axioms that, if you assume monotonicity, determine the same logic, determine different ones. They work very differently. And once again, a topic that we've only begun to explore is, even just for specifications of classical logic, what differences do you get if you relax the structural conditions, keep the same axioms or definitions of the logical connectives, but fiddle with the structure of the reason relations that stand behind them? You get all sorts of things. And ours is equivalent to our non-monotonic multi-succedent logic, so NMMS is the unlovely name of it. Under the full structural conditions, topological closure, it's just a specification of classical logic. But relax them, and it behaves very differently. It's much more expressively powerful than, say, Genson's original specification of classical logic. So that's the topic for next week, is codifying these substructural reason relations logically, introducing logical terminology to do that, and what kind of logic you get. So locus classicus for that is chapter 3 of the book, Wolf's thing, but I'll be presenting it here. Okay, well, see you next week, and we'll do some logic.